You know the story, right? The tortoise and the hare. But what if we could actually test it? I mean, for real. That's exactly what we're going to do today. We are building a computer simulation from the ground up to find out once and for all, can slow and steady really win the race?
Yeah, the moral of the story is a classic, right? Slow and steady wins the race. It's a fantastic lesson in just sticking with it. But if you think about it from, a purely logical point of view, does it actually hold up? Is it really possible?
And that's the big question we're tackling. We're not just going to sit around and guess. No way. We're going to build a simple simulation to figure out the exact conditions, what it would actually take for that tortoise to come out on top. So, let's get into it. Okay, so whenever you're trying to code something like this, or model anything complex, really, the golden rule is to start simple. You build the basic skeleton first, and then you add the fancy stuff. So for our first step, we're just going to simulate a super straightforward race. No naps, no tricks. Not yet, anyway. So what do we need to build a race? Let's break it down. It's actually pretty simple. You need to know how long the race is, right? The track length. You need to know how fast the tortoise is going, how fast the hare is going, and of course you need to keep track of where they are at any given moment. That's it. Those are the basic building blocks.
And here's what that looks like in code. See? It's not scary at all. We just turn those ideas into simple variables. We'll say the tortoise's speed is 1. The hare? Well, he's faster, so let's make his speed 2. And the race distance? Let's say 350. Boom. Just like that, we've set the stage for our race.
All right, we've got the rules. Now we just need the go button. And in coding, a simple loop is kind of like our starter pistol. It just keeps things moving forward, second by second, inch by inch, until one of them finally crosses that finish line. Now, in this basic version, let's be real, spoiler alert, the hare, being twice as fast, is gonna win every single time.
But that's a pretty boring story, isn't it? And it's not the one we all grew up with. So now it's time to add the secret ingredient, the hare's famous weakness, his laziness. This is where things get really interesting.
So, how do you actually program laziness? Sounds weird, but it's easier than you think. We just need to add a couple more rules to the game. We have to decide, okay, how long does he run before he gets cocky and decides to nap? How long is that nap going to be? And we need a little switch, a way to know if he's awake or asleep right now.
And once again, we turn those ideas into simple code. Let's just say he runs for 30 minutes and then conks out for a 20-minute nap. See that? With just 2 little lines of code, our whole simulation just got way more complex and a whole lot more fun.
And this right here is the simple logic that changes the entire race. At every single tick of the clock, the program is just asking one simple question. Is the hare napping? If he's awake, he moves forward. If he's napping, he stays put. That simple if this then that logic is what completely flips the script and finally gives our tortoise a shot.
So here we are, we've totally changed the rules of the game. The hare isn't just fast anymore, now he's fast, but he's also lazy. So the big question is that enough? Can our slow, steady hero actually pull off a win now?
Now, we could just have the program spit out some text at the end that says, tortoise wins. But come on, where's the fun in that? To really get a feel for what's going on, you've got to see it. So let's turn this into something we can actually watch. And there it is. The code we've been talking about on the left is what's making this animation on the right happen. You can literally watch the hare shoot out ahead, then just stop for his nap. And all the while, the tortoise is just chugging along. It totally brings the whole thing to life, right?
Okay, this is getting pretty cool, but it's still a little too perfect, a little too neat. Every time we run it, the exact same thing happens. But the real world isn't like that, is it? It's messy, it's random. So let's throw a little bit of that chaos into our race.
Just think about it. When you go for a run, do you maintain the exact same speed the entire time? Of course not. Nobody does. You have bursts of speed, you get tired and slow down. It's variable. To make our simulation feel more real, it should have that too.
And you can see the difference right here. On the left, that's our predictable race. Same thing every time. But on the right, we've added a bit of randomness. Now their speeds change just a little bit, all the time. It makes the whole race feel so much more alive, and you never know exactly how it's going to turn out.
So yeah, we've built this fun little race simulation, but what we've really been doing here is exploring a super powerful idea that's used in science and engineering all the time, building a simplified model of reality to understand it better. And the key concept here is something called abstraction. Now, that might sound like a fancy, complicated word, but all it really means is ignoring the stuff that doesn't matter. You simplify things down and focus only on the most important details for the question you're trying to answer.
So, think about it. What did we leave out of our race? Well, a ton of stuff. Our racers run in a perfectly straight line. They never swerve. We didn't think about how many calories they're burning, or the weather, or if the hare might get distracted by something. We ignored all of that, because for our one big question, can the tortoise win, the only things that really mattered were their speed and whether the hare was napping.
And that right there is the most important thing to understand. A good simulation isn't trying to be a perfect one-to-one copy of the real world. That's impossible. Its real power comes from being a simplified version that lets us zero in on the parts that matter most and see how they work together.
And this is what makes simulations so incredibly useful. What if the hare naps for 5 minutes longer? What if the tortoise finds a burst of energy and gets 10% faster? We don't have to just wonder. We can just tweak a number in the code, hit run, and instantly test out thousands of different what-if scenarios. It's like having a crystal ball for your problem.
So, back to our original question, can the tortoise beat the hare? Well, our little experiment shows that, yeah, he absolutely can, but only if the hare's naps are long enough and happen often enough to cancel out his raw speed. It's pretty amazing. And this exact same idea, simplifying reality to understand it, is used to model huge things like climate patterns or traffic flow in a city. So, it makes you wonder, right? What's a complex part of your world that a simple simulation could help you understand a little bit better?